All right, good morning, everybody. God bless you. This is SURDMAN Academy. So today, we are dealing on variation, and when you talk about variation, we say variation is used to describe the relationship that exists between two quantities. It's used to describe relationship between two quantities. That is a variation. So under variation, we have types of variation, which is the direct variation, indirect, or we call it inverse. We have the joint variation, and we have the partial variation. So today we'll be going on direct variation. Now, direct variation, talk about direct variation. When you say that something is when you talk about direct variation, it simply means that the two quantities which are related are increasing at the same time. So let's say we have something like V varies directly as P. What does it mean? It simply means as V is increasing, it simply means as V is increasing, that P is also increasing. That is all about direct variation. Both of them are increasing at the same time. Now, it also means that if this one is decreasing, it also means that if V is decreasing, also that P will also be decreasing. So direct simply means that what happens on the left hand side happens on the right hand side. Both of them increase or decrease in value at the same time. Now, another thing we need to understand is that to every variation there is what we call a constant. There must be an introduction of a constant. So now let's go to some cases and see how we can finish this up now. So case 1, let's say we have this. All right, say we have this. Now this is case 1. Question says, given that y varies directly as x when x is equals to 3, y equals to 6. Calculate y when x is 7.5 and x when y is 16.5. Now let's get down to this. The solution should be very easy. Now the first step is to introduce the, let's see, we have that y varies directly as x. That means this is the sign of variation. Y varies directly as x. So we have to replace this man. We now have y equals kx. Now we introduced a constant. Now removing the sign of variation, putting an equality sign. In the process of doing that, we introduce a constant k. Bear in mind that this constant can be any alphabet. So once you state it this way, then the next step is to remove this variation sign and putting an equality sign here. So process of doing that, you introduce a constant, which is k. I used k. You can use a or anything there. So we have y equals to kx. Now, first of all, let's find the values of our constant. Now, the first we said when x is 3. Question says when x is 3, that means k times 3, y is 6. So 3 times this will give us 6 equals 3k. So if you have to divide both sides by 3 in order to make your k subject formula, we have k equals 3 over 6 over 3, sorry. 6 divided by 3, we have 2. So that means our k is 2. So we have to take this back into the equation. Let's see our relationship. So taking it back into the equation, we have y equals to 2x. And this becomes our our relationship. This becomes the relationship in the question. Now, because in you need to find your relationship before you can be able to continue. Okay, now we've gotten this our relationship here. Now the next part now is to solve the next one, which says that calculate y when x is 7.5. So now first question I say calculate for y when x is 7.5. So we have here to be 2 times x being 7.5. 2 times 7.5 will give us 15. That means 2 times 7.5 will give us what? 15. Then the second question, II, says, let's go down. We'll see have and x when y is 16.5. So we should find x when y is 16.5. So now y becomes, now using this the same equation, we have when y becomes 16.5, using the same equation here, equals 2x. That means we are looking for what? We are looking for x. We divide both sides by the quotient of what? Of x, which is what? Which is 2. Divide here, so x becomes 16.5 divided 16.5 divided by 2. 16.5 divided by 2. We have 8.25. We have 8.25, and this is how you solve for direct variation. Thank you. If you get this, solve this next one. All right, try this. Thank you. You're welcome. I still remain SURDMAN. Bye-bye.